Hey, in this video we're actually going to be talking a lot about some vocabulary and using our identification skills. We've been in our functions unit. If you notice, the title of this unit is Unit 2 Functions. And today we're actually going to be talking about whether or not a given relation is a function. So let me first go ahead and just define a function real quick for you guys. A function is something where each input has only one output. Remember, we have these input-output tables? So a relation is actually just straight up any set of ordered pairs. So it can be anything. It could make a circle. It could make a straight line. It could be just one point plotted. It could be anything. And so then a function is a type of relation where each input has only one output. And an easy way to just going to be remembering that today and how to identify is just x can't repeat. That right there is going to be the thing we look at when we're looking at our domain, and we're going to see if any of the inputs repeat. And if the input repeats, then we do not have a function. But if none of the x's repeat, we're good to go and we have a function. So make sure you've got the definition here of relation, and I'm going to kind of go through and explain what I mean when a relation is a function, okay? Now first, just getting comfortable with relation, all right? Any set of ordered pairs. So here I have 4 ordered pairs, and when I plot them, they make this circle. Reviewing some vocab, that the domain is going to be this list of inputs right here. And so we have a 3, a 5, and a 7. Now right here you can see that this x repeats, so this is actually not going to be a function, so we're going to talk about that in a little bit. But for right now, just reviewing domain and then range. So then right here, our range is the 1, the 3, and the 5. Remember, if anything repeats, you only have to write it once. And here we have something repeating in both the domain and the range, and we're going to talk about why it's okay for something like this to happen, but it's not okay for something like this to happen. All right, now over here for this one, we have just 3 ordered pairs, and the domain right here from least to greatest is listed in these braces. And remember, if the range is just one number, you have a flat line. And so you might remember that this is the equation y equals 3, because no matter what the input is, the output is 3. Another thing I want to remind you guys of is that if you know that it crosses through 3 right here, and then to get to the next point, you don't have to rise any. You remember that the slope is 0 over, and then it doesn't matter which point you go to, 0 divided by anything is still just going to be a 0. So friendly reminder that that has a 0 slope. 0 times x is just 0. And then it crossed at the plus 3. So then 0 plus 3 is 3, and that's why we get the equation equals just a straight up number. Now relations can be given here as a graph. We could see the table of values, or we could see a list like this. And so here we have a domain. Let's just practice again identifying a domain if we have a list of inputs and outputs. So we have a -1 and a 0, an 8 and a 10. So from least to greatest, we have -1, 0, 8, and 10. It's okay if your little braces aren't perfect. Nobody's are. And then for the range, it's the output. So there's this 4, this -1, this 3, and this -2. All right, so from least to greatest, that's the -2, -1, 3, and then 4. And then we can't forget our little braces. So a relation, y'all, is just any set of ordered pairs, and it doesn't really matter what it looks like, okay? Now, if the ordered pairs pass this test where the x's don't repeat, then we get to call it a function. And every single thing that we've actually looked at so far in this unit has been a function. So today I'm going to kind of show you guys what some non-functions look like so that you can see like, oh yeah, we have definitely been dealing with functions so far in this unit. All right, let's just try to practice identifying real quick with these 2 problems. For this first question, is this a function? So to answer it, you just got to look at the domain and make sure that none of these numbers repeat. And since none of these numbers repeat in the domain, yes, this is a function. Okay? Now let's say you're asked to find which one is not a function. Okay, so this means we're trying to find something where the x's are repeating. Now here I see a 4, a 3, a 2, and a 1. That one's a function. That one's good to go. Here I see an input of a 3, an input of 2, an input of 1, and an input of 0 function. Here I see a 6, a 5, a 4, and a 3 function. And with this one I see a 2, a -7, a 1, and a -7. Right there at x equals -7, this one is not a function. Okay, this one's not the function. So today you're going to be able to tell me if it's not a function, where it's not a function. Now before I go on any further, I want to kind of just remind you guys that there was this thing earlier in the school year where we said all numbers are real. And then for the real numbers, we basically broke it down and said, okay, it's either rational or irrational. And you might remember that the irrational numbers were anything with pi, things that were not perfect squares. And then straight up, like if you saw a decimal that went on and didn't have any sort of pattern, those were irrational. Now this isn't in your notes, but the reason that I'm reminding you guys of this is because in this unit, it's kind of similar, where we're saying everything on the coordinate plane can be called a relation. Okay, that's kind of like the top word. And then you basically decide if it's a function or not a function. And so the not function is kind of like the weird one, kind of like how irrational is just the weird stuff. And once we said it was rational, you guys might remember that we further could categorize that stuff into integer, whole, and then natural numbers. So for functions, there's lots of different types of functions too. There's linear functions, there's parabolic functions, and I'm actually going to explain what a parabola is in a second, but the word I just said was parabolic to describe it. There's quadratic functions, there's cubic functions, there's so many. Right now we're just dealing with y equals x as our parent graph. There is y equals x squareds out there as a parent graph. There's y equals x cubes out there as a parent graph. So there's lots of different types of functions, and we're just getting started this school year with y equals x as our parent graph. Now let me kind of keep going with this. Again, this is not in your notes, so just kind of follow along with me here. Take a look at this table of values. Now it is a function because none of these inputs repeat. Now I don't want you guys to get confused. You guys see over here that the y's do repeat, but let's talk about why this is okay. What can I do to 3 to get 9 that I could also do to a -3 to get 9? It's the same as what I would do to 4 to get 16 or a -4 to get 16. So think about it. 3 squared is 9. And if you do a -3 times a -3, you get a +9 as well. So this right here is y equals x squared. This is the parabola or parabolic function I mentioned a second ago, which means in the world of math, we do see situations where the y's mathematically can repeat. And when we plot these points, I'm just going to sketch it very quickly over here. If I were to go roughly over 3 up 9, back 3 up 9, over 4 up 16, back 4 up 16. Think about if you did over 1, 1 squared, 1, 1. If you did a -1 times -1, you'd still get a 1. 0 squared is just 0. Let's do 2 squareds real quick. If you did 2 times 2, you'd get a 4, so that'd be about here-ish. And then -2 up 4 would be about here-ish. So this makes, I'm slightly off, but it makes about a U-shaped graph. And again, this is something called a parabola. And I wanted you guys to go ahead and see this because I think it's important to see math situations where the outputs can repeat. Now, if I scroll down a little bit, let's take a look at this table of values. Do you see how it's meant to be +3, +3, +3, +3? But then right here, if I have the same input in the same equation, why all of a sudden do I have a different output? That's the weird thing. This means something's not functioning. So right here, mathematically, it doesn't make sense that I can take this number and plug it into an equation and get a 5. And then I'm plugging in the same number into the same equation, and I get a different thing, no, 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 no. This is not functioning. Okay, so this one is not a function. Not a function. And on the graph over here, I'm going to show you guys how to visually spot now if something is not a function. So if I plot this, I got back 1, up 2. I'm just, again, roughly plotting this. 0, 3. If I go over 1, whoops, over 1, up 4. I go over 2, up 5. And then over 2, up 6. Right here, if I were to have drawn a vertical line, since it goes through 2 points, that is when you spot that something's not a function. This thing is called the vertical line test. When you take a vertical line and put it through any of the points, if it goes through 2 points at once, it fails the vertical line test, and you can see right here we can spot where it fails at x equals 2. And now that you guys know about vertical equations, think about what the equation of this line would be. The equation of this line right here, if it crosses, and it's up and down and crosses through the x-axis, this is the equation of the line y equals x2. So there is where it fails. Now if I want to take this vertical line and try it up here with the parabola, let me show you guys that it passes at any given point. It's only going to cross through my purple U one time, no matter where I put this thing. So this passes the vertical line test. Now let's come back over here to the top part of your notes. Back to this first one. If I draw a line right here, it fails at x equals 5. And right here in the table of values, that is where the input's repeated. So that one was not a function. Now over here, no matter where I put it, it's going to pass the vertical line test. It only hits through 1 point. All right? So that's what the bottom part of this page is all about, y'all. That's the vertical line test. It's simply used to determine if a graph is a function or not. And I've got 3 graphs here, and I've got my vertical line, so we can just try it. You can see that circles are going to fail the vertical line test at a lot of different places. I could draw it here, and it would fail the vertical line test at x equals -2, because it hits right there. It fails. I could even move my line over. It fails there. It fails a lot of places, actually. So this first one is definitely not a function. Okay. Now let's take a look at the next one. No matter where I draw this, yep, see? It's only going to hit it once. Like, for example, right there, it only passes once. So this one is a function. And that's actually the heart-shaped V right there. That's actually for absolute value. If you take the absolute value of any number, it's positive, and then like if you take a negative number, its absolute value is also positive up here. So you'll explore absolute value equations next year. And then for this last one, if I make this go through all these points, it's only hitting once so far everywhere I go, even here. Oh, but right there at -1, it fails. So this one is also not a function. Oops, sorry, I was trying to copy and paste that. Oh well, not a function, and it fails at x equals -1. So fails at x equals -1. Not a function. All right. And now let's flip over and continue to try to practice these. So we've got 1, 2, 3, 4 more graphs at the top of your next page. And I want you to just kind of look real quick and see if you can determine, based on the vertical line test, if you think you have a function or not a function. So I can kind of drag my red line over to help you see right here. So I think you guys could see it's going to fail, boom, boom. So this one, not a function. Okay. All right, now the next one. No matter where I put this, it only hits through my line once. So that one is a function. Now we finally see a straight up vertical line. And we're going to talk about now maybe why some of the stuff from our previous videos might make sense here. So I know it's kind of small and blurry and a little tough to tell. We might have to estimate. But I'm thinking this is back 1, 2, 3, I mean, it kind of looks like it's a little bit past 4, but let's just pretend that's x equals -4. Okay, let's just pretend for the video. All right, now let's talk about everything you know about this equation, x equals -4. You guys know that the slope of this line is undefined. And maybe now it makes sense that this slope is undefined because this isn't even a function. Functions have slopes, or they can have slopes. So right here, if we see this vertical up-down line, it is the ultimate fail of the vertical line test. This entire thing is x equals -4, so all of the inputs repeat, actually, so it fails every single place that you could possibly imagine. So this is the weird one. This is the only equation in our entire unit, like these up-down lines, these are the ones that start with x equals, and they have an undefined slope, and they are definitely not functions. And now last but not least, we have another parabola, and this will definitely pass the vertical line test no matter where we put that red line, so that one is a function. Now the rest of the video is just going to be me helping you get comfortable with identifying functions or not in function, and then how to replace values to either make it a function or not a function. So for this first one right here, select all of the values from the gray box which would make the relation a function. So remember, a relation, bunch of random ordered pairs. Now for it to be a function, none of the x's can repeat. So I have the x of 4, so I cannot pick that one. If I already have a -3, we couldn't have another -3, but I don't see one, so we're okay. I'm trying to figure out what this could be. If I already have a -5, it can't be this. So this number right here, it could be a 2, and none of my x's would repeat. It could be a 0, and none of my x's would repeat. It could be any of these, and none of my x's would repeat. All right, now over here for this one, again, same concept. A 2, a -1, and a 0 are already inputs. So if I want this to be able to be a function, I couldn't pick a 2, I couldn't pick a 0, and I couldn't pick this -1. But any of the rest of these numbers here would be fair game, and if they were listed right there, then I could say, yup, that relation is a function. All right, so we've seen kind of just lists. Now let's go back to the table of values. We talked a lot earlier in the video about the vertical line test. Now let's go back to tables of values and seeing if they're just a function or not, okay? So for this table value A, we got a -2, a 12, a 3, and a 7. None of these things in the domain repeat, so we have a function. All right, for the domain, I see no repeating numbers here. Function. And for the last one, right here, at x equals 13, that is not a function. All right, so it is that simple. And for this one, choosing a set of ordered pairs that represent a function. All right, so for this relation, I have a -1, a 1, and a 1 in my domain, so that repeats, so this one is not a function. All right, -1, 1, 3, 6. Nothing in my domain repeated there, so that relation is a function. All right, I got a -5 and a -5. Uh-oh, no function. 0, 0, nope. In fact, even again at the 1 and the 1. All right, so I've got a 1, a 7, and a 4. That one's good. And a -1, a -3, oop, another -3, so that repeated, so not a function. All right, and now the classic true or false. So all relations are functions. Are any set of ordered pairs called functions? No, this is false. But if we said it's a function, can we also say it's a relation? We sure can. Let me go back to my diagram here. You might remember with the true-false stuff, if I said true or false, all real numbers are rational. That was false. But if I said true or false, everything that's rational is real, yes, that's true. So back down to here, Are all relations considered functions? No. But if we call it a function, then yes, it has to be a relation, which is what that is saying for the last true or false one. All relations, or excuse me, all functions are relations. So hopefully now you have a better idea of this vocabulary term that we're calling our entire unit. We've been looking, again, with our parent graph, we've been looking at just linear functions this school year. Everything we've done, we've either given the line some slope, or we've moved it up and down on the y-axis with like a plus or a minus number here. So we've been graphing straight lines, and they might have positive slopes. They might have a no slope. That might be a flat line. It could be a negative slope, but we've been looking at straight lines. And then next school year, you guys are going to be getting into parabolas. You guys are even going to be looking, like I said, at cubic functions, where you have x cubed. You all are going to be looking at absolute value of things, and potentially even into quartics right there. All right? So that takes care of this video. Thank you for watching.